In the standard, we were thinking on how we can enhance reliability, keep the reliability up while saving some bandwidth. And for this, we developed a small machine learning algorithm. This is a simple one. This is the application transmitting over the TSN thing, and there's two user equipments transmitting at the same time. So we're reading the radio conditions. The RSRP receives signal Q, quality, power, and SNR. We cluster them according to those conditions. And after clustering into green, orange, and red conditions, and if there's any degradation in the link, we accept it. Because we're trying to protect reliability, transmission. So even if there's false alarms, very simple one, K-means. And then when you're moving out back from red to orange, you have to get the hysteresis running here. So I can transition you safely from that state to another state. So the FSM can maintain reliability all the time. And this is the asymmetric hysteresis algorithm, and this algorithm will stop and turn on this function, TSN. When it's working on, two transmission at the same time. When it's off, one of the UAs will be used for transmission.
You have a demo, right?
Yeah, I have a demo. So here's a kind of experiment we did published at the IoT conference. We have the measurements, the clustering, and the state after the hysteresis. And this is the same thing for the second one. The second one, as you can see, it's oscillative, changing between states, but the hysteresis will keep it in the same state, no matter what. Now on the reliability aspect, we can see when reliability is on, we have 2 times the bandwidth, amount of transmitted packets. When reliability is off, we switch it off the TSN function, and we get the lower amount of consumption. Now I'll show you a real demo on this. We have a small robot, and this robot is connected to and those 2 UAs are reading the radio conditions, clustering them. So the first stage we're doing some training. So we started now. So this is the first part, is the radio conditions on the first UE, radio conditions on the second UE. And over time, the clustering algorithm is taking a snapshot of the buffer and making the clusters. We can see one of the UEs stays in the same state. There's no changes in that one. The other one is a kind of between 2 different states. And we have a shielding fabric here. Shielding fabric is used to challenge the radio conditions. So if we put this one here, you can see there's a degradation on one of the UEs. Look, you see? When I put more stuff, the power control feature will be activated and transmit on a higher power to compensate for the loss I'm causing. And the same thing when you increase the power, increase the quality, increase the SNR. So that's a kind of challenging the radio conditions and making sure we have different conditions. Now, after a certain amount of samples, there's a criteria to stop the training process. And this criteria is enough amount of samples and some silhouette score. It's a K-means score to show you how diverse or how distinct are your clusters. When it's meeting a certain amount, which is 300 samples and 0.4 silhouette score, so we're done. And you can see here on the screen, we have a completed training now. I can download the picture of that training. And this is how things in the system. So we have a clear cluster on the red side and the green side. This is a good cluster, whereas the SNR is 20. And when things gets worse, like as you can see here, it's 9. So this is a orange cluster, and this is 8, which is the red cluster. Naturally, there's a red and green, but we have to enforce this orange so we can have a smooth transmission between red and green. So naturally, those guys are the same cluster. If we apply 2 clustering in the K-means, we will get a higher silhouette score, but we don't need that. We need to have something in between so we can distinguish when the user equipment is moving. Now I'll move to the testing phase. Now in testing phase, I'll be using what I learned over the first one and see how the conditions are changing. So now we have one UE is with the reading the current radio measurements. Now this is the clustering. The clustering says it's red, orange, and back red, then orange, fluctuating. As a hysteresis mechanism, everyone has to start in red, so we can keep the TSN up and running. After some time, if you continually telling me on orange, orange, orange for a long time, then I'll believe you and I'll transition the UE from red to orange. This one looks like it's in the same state. We are not doing any changes so far. Now, hopefully, if this is stays, no, it's bounce in, bounce back to the green state. But we can't challenge them to change the state. And challenging them is we can use the same trick. See? So we increase the power. Increasing the power will change the user equipment to green state. So if I can ask you, Matt, to keep this on the for some time.
For what?
Yeah, can I ask you to hold it?
Oh, yeah.
For some time without touching it, otherwise it's going to. So as you can see here, the UE is trying to recover from the.
By doing this, you are cutting one of the backs.
We are challenging the air interface adaptation. So it's changing the MCS, changing the power allocation, changing some of those mechanisms. Because if I challenge them, the UE will be fluctuating, and I can see some savings on the bandwidth. Yeah, but this is the hysteresis is we don't take advantage of those because those are a kind of for short time enhancements. I don't take them. I need something sustained stays for some time so I can make a decision on this. So can you switch back to the other one?
It was
Now we're
looking
challenging
good.
the other one. That's good. It's in orange state. That's good. Now we're challenging the other one. We're expecting to have some change now on the UE. Now things are getting worse. The UE stays in red. It's red all this time. So staying in red will prevent us from saving any bandwidth until it transitions to the green state. And this guy now in a green state.
I think because we are staying around it.
I'm myself in business and services.
So yeah, with this kind of mechanism, we can see how we can enhance the reliability at the same time, saving some bandwidth. One of the UEs now is staying in red state, so we can't transition the TSN to the off state. Yeah, but that's more or less what TSN can do for 5G systems.